Yes, class. So in the last class, we had started with what? In the last class, we had completed resolution of vectors. So I think this class, we had it on Friday, right? On Friday, we completed this lesson, this topic. Now see, what was actually in resolution of vectors? So basically what happens, you have a vector and that vector is not aligned with any of the axes. It is in a random plane that is making angle theta with the either the y-axis or the x-axis. Fine. So here the vector A is there, for example, on the screen that you can see. So A vector is making theta angle with the x-axis, right? Now theta angle is making being made with the x-axis. Now we have to resolve it because you can use a vector, but right now a vector is not in any of the axes. It is either in x-axis or in y-axis. So you have to perform the resolution of vectors. You have to resolve it into xy plane because your conditions require to resolve all the vectors in xy plane. Fine. So the method, whatever is the angle made with the axis, that axis, the resolution involves cos component. For example, if a vector is over here, then you will notice that over here, this side, because this angle is made with this, we find it as theta. So this is a cos theta over here. And the perpendicular one, the one that is left, the perpendicular one is what? That is termed as sine theta. So if you have any vectors with you, you can resolve them into different components. For example, let's say there's a vector, x vector is there. For example, let's say this is x vector, fine. Now, x vector is making, this is x vector making angle theta, or let's choose the value of theta as 30 degree with the x-axis. Now, this is not of any use. I want to resolve these. So how will I use? X will be x cos 30 degree along the x-axis. Reason that theta or the angle is being made with the x-axis. And the other one, this becomes x sine 30 degree. Fine. Whatever is the perpendicular one left, that you call as what? Sine theta. So sine and cos, these are the two rectangular components, and we had discussed these. So the students who were not present in the last class, just see the recording. I think this is a very important topic, resolution of vectors. Now, after resolution of vectors, the last topic that you have is the dot product and cross product. Now, why do we need dot product or cross product, or what's the need of this? Basically, it's the multiplication of vectors. This is the multiplication of vectors. Now, vector can be multiplied with a scalar quantity, vector can be multiplied with a vector quantity, vector can be multiplied with a number also. You can see three cases: vector with number, then you see vector with scalar. For example, if I say velocity is getting multiplied with distance, so that is a vector quantity getting multiplied with a distance. So this is vector with a scalar. And then you have the last one. This is what? Vector with a vector. Force multiplied by mass, or not force multiplied by mass. Mass can be written as what? Force divided by acceleration. In the multiplication of vectors, you can write any value. Force multiplied by velocity gives you power. So that is also one of the formulas. So this is vector with vector. All right, so under these three headings, we are going to study multiplication of vectors, fine? Vector with a number, this can be positive, this can be negative as well. And what happens? What happens is that the magnitude becomes n times. If n is any number, you have n here is any number. N is any number. Fine. Regarding the units, here the units remain the same. The units remain the same. Now these are certain introductory points. We'll actually study with what is actually dot product and when to use cross product. Before that, we are actually trying to study what is meant by these. So whenever vector is there with a number, you will be able to deal with it. These are just theoretical points. These are of no use to you. You can just remember magnitude and unit remains same. Fine. This is normal. This is like, I'll give you an example. What actually this is. This side is, for example, if I say force is equal to 2 I cap Newton. Fine. I cap, now you all are aware of the universal vectors. Fine. And a number is 3, let's say. So n into f, if I write, that becomes 3 into 2 I cap Newton. That gives me 6 I cap Newton. Now, if it is minus 2 I cap, then I'll get minus 6 I cap. That's why I said it can be positive or it can be negative. Like this, you can choose the examples. Then what was there? The second heading included vector with a scalar. If you have a scalar quantity you are multiplying, so this is exactly the same vector with a number. Fine. For example, here also magnitude becomes n time the unit remains the same. I'll write it down. Here magnitude becomes n times. Why? Because n here is a scalar now. N here is a scalar. Now what is happening? N is a scalar for you. So here n is a random number only. No, what is a scalar quantity? It has no direction with itself. So if there is no direction associated, then there is no difference between a normal number and a vector and a scalar quantity. So this is exactly the same story. It's just that unit will be the same and it can happen here. Direction is also the same. I'll give you example. See, here the unit will also be the same. Here also unit will be the same. Still here also the units will be the same because there is no change. It's like you're multiplying a number. For example, if I tell you acceleration is, let's say, 2 I cap meter per second square, fine, and I tell you mass of an object is, let's say, 2 kgs. If I say mass is 2 kgs, acceleration, tell me the force. Force is what? Force is m into a. How to prove this? How did we get this? Revision of this will be dealt in laws of motion. So F is equal to ma. Mass multiplied by acceleration. This gives you what? 4 I cap. And unit will be kg meter per second square, which we write it as Newton. No need to go into the details of force. But what was important here? Was there even any difference in the examples that I took in the case of the first case and the second case? There wasn't any difference because scalar is also just a number. Units are associated. That just, it's the difference along with it. That's why we have a separate section. Vector with a vector, you can get a scalar product for which you have dot product, which we apply. And when you have vector multiplied with a vector, then you have vector product. For this, we use cross product. Fine. So just note down this table. We'll start with directly scalar product because there is nothing that you have to study with vector with number or vector with scalar. All right, note it down. We'll start with dot product first. What was the syllabus of the test that I told you? I think I've mentioned you about the test on Wednesday that I'll take. Vectors, did I say? Aisha, do you remember? Anyone else? Maha. I think I've mentioned about the test to you people. Was it just vectors?
Yes, just vectors.
Just vectors, okay. So I'll take before dot and cross product because this topic is done today only. There will not be so much time for revision for you people. Before dot and cross product, till the resolution of vectors. Dot and cross product, I'll take it separately. Done, class? Written?
Yes, ma'am.
Let's start with now scalar product or the dot product, which we say. Now, see, scalar product or dot product is what? We even call the dot product that we use as scalar product also. So this is the scalar product or the dot product. But in common terms, we'll be using the term dot product only. Fine. So this is what? This is scalar product or dot product. Now, I think dot product is easier than your cross product. So it's better if you try to understand from here only what is actually meant by dot product. Fine. So in dot product, what will happen? You will be having two vectors. I'll show. See, in dot product, what happens? Dot product or multiplication of vectors can be solved in Cartesian form as well as it can be solved in your polar form. So polar form you have as well as you have Cartesian form. So first we'll start with polar form, but we'll complete Cartesian form today only. At least dot product we should be able to complete it in today's class. Otherwise your syllabus will lag behind a lot. Now if two products are there, for example, this is B, not two products, I mean two vectors are there. This is vector A. Fine, A and B vectors are there. They are making an angle of theta. Fine, theta is angle that has been made with them. So dot product, we write it with the help of dot, obviously. Cross is written with the help of a cross. Fine, that is clear. Now here what happens? A dot B is what? A dot B is the dot product of AB. Means you are multiplying a vector A with the vector B. This is the dot product that you're taking. So here, how will you write it? You take the magnitude of A. This is how we represent the magnitude. In the first class of vectors, we have seen this. Then you take the magnitude of the vector B and then cos theta. Now magnitude, you know how to calculate, how to write the magnitudes of the vectors, which we have already studied earlier. Magnitudes is taken with the help, the way we write under root with the squares of all the coefficients of I cap, J cap, K cap and all these. Fine. So here in case of scalar product or dot product, what happens? A dot B is there. You take the magnitude of the vector A. For example, force is written as 3 Newton per kg meter square, or force is written, let's say 3 Newton. Fine. Force is written as 3 Newton. Complete force will be written how? Complete force will be written as, let's say, 3 minus 3 I cap. So what will you write? You will just write 3. That will be the magnitude of it. So magnitude of first vector, and by whichever method you know how to take out the magnitude of any vector. So that is the first vector multiplied by the second vector's magnitude multiplied by the cosine of their angle that they are subtending at the center or making it. So this I'll directly write down whenever we'll be using A dot B will be equal to what? AB cos theta. Remember this statement. This statement will be used. This statement will only be used. For example, let's say, let me give you an example. In Cartesian form also, you know how to write the magnitude of the vectors. Yes, you know how to write in terms of Cartesian form. Cartesian form means I cap, J cap, K cap. There you have what? Cartesian system, you take under root, then you write coefficient square of I cap plus coefficient square of J cap plus coefficient square of K cap. That way we do in Cartesian form. In polar form, no need to do that. Just see whatever is written. For example, this is 30 degree, or let's take it as 60 degree. This is 60 degree. This velocity is minus 3 in some angle it is given, or let's just write meter per second. Fine. And this is v2, and this is v1 velocity, which is 5 meter per second. And I am asking you to find out the dot product of v1 and v2. So here in polar form, what you will write: the magnitude of the first vector v1, then the magnitude of the second vector v2 multiplied by the cos theta. Magnitude of the first vector, that is 5, multiplied by magnitude of the second vector 3. You will not consider minus sign now, so that is 3. And cos theta is what? This will be cos 60 degree, which is half. So that becomes 15 divided by 2, which is 7.5 meter per second. Like this we will solve if you have a dot product. Now here the topic doesn't end. You have certain properties also that you have to keep in mind. Fine. These properties are generally not asked in your exam to write down all these points. In the exam, you're just asked to solve this. More or less, no, whenever I'm telling you vectors, I have mentioned this before also, that vectors will what happen? Vectors will get utilized in your numericals whenever you solve. Separately, vectors is asked, but in long term, vectors will be used wherever you will be solving questions. So here what happens? This is the first property. If I talk about the properties, first property is that result is scalar. Though you are multiplying a vector with a vector, but the result that you're obtaining, it's a scalar quantity that you will obtain whenever you do dot product. For example, force into displacement, or F dot S, that gives you work done. And energies and work done are always scalar in nature. They are never written as vectors. They don't have any directions. So this is one of the examples. Whenever you take the dot product of two quantities, the third quantity is the scalar. So first property keep in mind is that result is scalar. All right. Now second is that it is commutative. Commutative means if you have A dot B, if I had V1 dot V2, even if I here reverse V2 and V1, instead of V1 writing first, if I write V2 first, what will be the difference? 3 will come here, 5 will come here. Will there be any answer? Will there be any difference in our answer? No. It will still be 3 into 5. That will give you 15 only. So here what will happen? This is commutative. This means if A dot B is written, you can intershift it and you can write it as B dot A, which is not possible, you'll notice, in case of scalar quantities. So this is commutative. Commutative means A dot B is equal to B dot A. Fine. Then regarding the perpendicular vectors, if you have perpendicular vectors, then how will you solve it? See, for perpendicular vectors, straight away your cos theta will be what? 90 degrees. And cos 90's value is what? Abdullah, what's the value of cos 90? Yes, Abdullah? Devangi?
0.
0. Cos 90 is 0. So third point, if you have perpendicular vectors present. So for perpendicular vectors, it is 0. Perpendicular vectors, dot product is always 0. So sometimes in your questions also you will come across, especially in gravitation and laws of motion, you will notice there sometimes you have to prove two vectors, or you have to show that resultant is 0. So you use the dot product method usually. This is what, see, AB cos 90 degree will give you 0. Or even if it is in terms of I cap, J cap, no, in terms of Cartesian form, then also it will be 0. Because class, I cap dot J cap, these two are perpendicular, x-axis and y-axis, both are perpendicular to each other. I dot J is 0. J dot K is 0. The other one, I dot J is 0, J dot K is 0, and K dot I. K cap dot I cap, this is 0. So even if you have perpendicular vectors in Cartesian form, the resultant is 0. Fine. So three properties we have seen. First is result is scalar. Second property we have seen, it is commutative. You can shift it. And third one we have seen, it is perpendicular. There are two more properties that let's discuss regarding the parallel vectors. See, in case of parallel vectors, it's just the fact that you get the maximum value of vectors, because cos 0 degree comes into action, and cos 0 degree is what? 1. So if you have parallel vectors, then let's say this is a vector, this is b vector. So theta is what? 0 degree between them. So here a dot b will be what? A b cos 0 degree. So a dot b will give you ab. And this is what? This is its maximum value. A dot b, this is the maximum value of it. Even in terms of Cartesian form, you have to write parallel means I dot I, j dot j, k dot k. That is always 1. Fine. In terms of Cartesian form also, I cap will overlap with I cap if you are taking or considering about parallel vectors. So I cap is equal to j cap is equal to k cap, which is equal to 1. Fine. This is it. And the last properties is about the square of the product. Till here, till fourth point, all the properties were important. Fifth property is basically, see, if you have a dot a, you are multiplying with the same product. So square of a vector is what? Square of a vector, if it is a dot a, means both the vectors are in the same plane. So what according to you should be the angle here that I should choose? Nothing is mentioned. Only a dot a is mentioned. Can anyone think of the angle that can be written over here? Angle is there, but it is not mentioned. What according to you should be the angle? Maha, can you try?
0.
0. See, it's the same vector. If this is one vector, so this multiplied by this, it will overlap. That will be a kind of parallel vector only. So magnitude of a cos 0 degree. This will give you what? A square. Fine. So square of a vector is what? It's the dot product with the product itself. Dot product of the same. So just in case this point is not mostly used in your calculations, but till here all the properties were important. Fine. And examples of dot product you can include. For example, work done is calculated as F dot S. In lower classes we study it is force multiplied by displacement, but in actuality it is the force dot displacement, dot product of it. Or even power. Power is what? Force dot velocity, F dot V, dot product of force and velocities. Fine. So these are certain points. Just note it down. Wherever you are having any trouble, just ask me. From here, you have to note it down. No? Devangi, you were not given the link for Friday's class. Yes, it was rescheduled because on Monday I didn't have the class. It was raining heavily in Delhi. So I had to reschedule the class on Friday instead of Monday. So that Monday's class was conducted on Friday. I'll share the link with you and I'll inform the team also
Okay,
to
ma'am.
send you the links. All right. Now see the dot product in Cartesian form. So this is easy. In case of dot product, you don't have to form the determinant system. So this becomes easier. So dot product in Cartesian form, let's take two vectors. A1 I cap plus A2 J cap plus A3 K cap. This can be any vector. Coefficient can be anything, 5 I cap minus 3 J cap plus 2 K cap. In any manner, it can be any values. Fine. And B vector is also there. So this is B1 I cap plus B2 J cap plus B3 K cap. Now, when you're taking the dot production of the vectors, this is, I think, the last theory portion. From now, we'll be just doing the questions on dot product. So here what will happen? Each coefficient will get multiplied. When you will write A dot B, all the like terms will get multiplied. Like terms will get multiplied in the sense this gets multiplied. And you must have written right now only I dot I. I cap dot I cap is what? I dot I cap is 1. So you are left with A1 B1 plus. Now you have second like term as what? A2 B2 J cap. J cap dot J cap will be 1. What are you left with now? A2 multiplied by B2. So A2 B2 plus the last term that you have is A3 B3 because K cap dot K cap will be 1. So dot products multiplication is easier. See, these things will become a little trickier and tougher in case of scalar product, vector product, that is your cross product, because there you don't have the liberty to change things. So you have a set pattern of the processes to follow. So this is A3 B3. For example, let's take two vectors. Example, A vector is 3 I cap minus 3 J cap plus 4 K cap. Randomly I have taken any vector. B is I cap minus J cap minus K cap. Fine. Now A dot B when I'll write. When I'll take the dot product of this and this. So these two will get multiplied. Aisha, can you try the first one? What should I write over here? Aisha. 3 into 1. Perfect. Coefficient of I cap is 3. Coefficient of I cap in B vector is 1. 3 multiplied by 1 will give you 3 only. And why are we not writing I cap along? Because I cap dot I cap will give you 1. Right? So here was the difference. Aram, can you try this one?
3 into 1.
3 into 1. See the coefficients properly, Aram? Both the coefficients. 1 and 3. Something else also?
Minus?
Minus 3 into minus 1. Fine. Okay. See, minus 3 is the coefficient of J cap and minus 1 is the coefficient of J cap here. So minus 3 into minus 1, that will give you 3 back. That is a different thing. So here what will happen? This will be 3 plus 3. And yes, Fatima, can you try the last one? This one? What should be the answer?
1 plus 4 minus 1.
Exactly. 4 multiplied by minus 1. That gives you minus 4. So what did we get? 3 plus 3 is 6. Minus 4 is 2. So this was the vector that you had. These two were the vectors that you had. And final answer is 2 only. Fine. One question is there. Let me not write everything. See what is the gist of the question. Question says a force is given. Force's value is given 2 I cap plus 3 J cap minus 5 K cap. This is the force unit vectors along with the unit vectors. Fine. Then it says this much amount of force acts on a body due to a force, and it displaces. The main point is it displaces the body from A point. Now coordinates of A are mentioned. So coordinates of A will be what? Coordinates of A means what? X, Y, and Z. So this will be 2, 3, 0 meters, 2. So initial displacement or initial position is this 2B, which is 4, 2, 1 meters. You have to calculate the work done. So again, this question is also from your lesson work, energy, and power, but the whole concept, nothing physics is applied over here, just your vectors are applied. Now see, once we'll solve this, what actually is A vector? Position at A. You have to write it in terms of I cap, J cap, and K cap. This means I cap is given. This means J cap is given. Coefficient of K cap is given. X, Y, Z. Fine. So R will be what? 2I cap plus 3J cap plus 0K cap. Or even if you wish, you can write it as 2I cap plus 3J cap. That's it. Because 0K cap means nothing. Now, RB. RB will be what? 4I cap plus 2J cap plus 1K cap, or I can write it as K cap. 1K cap can be written as 4I cap plus 2J cap plus K cap. Now, there are three quantities over here. What's the formula of work done? Formula of work done I have made you write also today. It's F dot S. Or here I'll say F dot R. Means force and the dot product of R. So here we have to know the position. Position vector we know. Now RA is also given, RB is also given. So which position you should write? So it's the displacement. Initial position is given, final position is given. How do we calculate the displacement? We actually take the difference. That gives us the displacement if you write the difference. So position vector will be what? RAB. This will be vector B, because this is the final position minus the initial position, that is A vector here. Got it, class? So subtraction of Cartesian form we have studied. This is what? 4I cap plus 2J cap plus K cap minus 2I cap. This will also become minus now, so minus 3J cap. This will give you what? This will give you position vector. Fine, this will just give you with the position vector. So what is the position vector that has been obtained? Because it's the initial point is mentioned and the final point is mentioned. So what's the displacement? It's actually the difference between these. That's why we are actually calculating the displacement first. So 4I cap minus 2I cap gives 2I cap plus 2J cap minus 3J cap minus J cap plus K cap, no opponent to be solved, plus K cap only. This is the position vector. And the value of force was already 2I cap plus 3J cap minus 5K cap. Now when I'll write down work done, that will be F dot R. So F dot R means this will be 2 multiplied by 2 plus, this is I cap term is solved. This is minus 1 multiplied by 3, J cap term is solved, plus 1 multiplied by minus 5. So what do we have? 4 minus 3 minus 5. This gives you what? 4 minus 8, that is minus 4 joules. This is your work done. All right, guys, like this you have to solve the questions based on the Cartesian form. So note down the Cartesian form as well. From here you have to write it down. No? C class, we have to find out the angle between them. So if you remember, what was actually, this is actually a combination of polar and Cartesian form. In polar form, you have the angle, and in Cartesian form, you just don't have the angle, you have it in terms of I cap, J cap, and K cap. Now, if I write A dot B, what will be A dot B equal to? Magnitude of A multiplied by magnitude of B cos theta. So this much we can at least solve. So see, what are we left with now? A dot B will be what? A dot B, let's solve A dot B first. So A dot B will be 1 into 1 will give you 1. 2 into minus 2 gives you minus 4. And what is this? 3 into minus 5, minus 15 we have. Right? So what are we left with? 1 minus 19, that is minus 18. Right? Now A is magnitude. This is a revision of all of Cartesian form also of vectors. Square of the coefficient of I cap, that is 1 square, plus coefficient of this square of coefficient of J cap, that is 2 square, plus coefficient square, that is 3. So this becomes 3 complete whole square. Right? Now C class, what are we left with? We are left with under root 1 plus 4 plus 9. Hey, bachega na? So this is 14. So A vector's magnitude is 14. Now vector B's magnitude. What was the vector? 1 square, minus 2 square, and minus 5 square. Coefficient of I cap square, coefficient of J cap square, and square of coefficient of K cap. So what are we left with here? 1 plus 4 plus 25. So what is this? 5 plus 25, this is 30, right? So under root 30, and here we have under root 14. Now cos theta will be equal to what? Cos theta will be equal to A dot B divided by magnitude of A and magnitude of B. A dot B came out to be what? Minus 18. And this is under root 14 multiplied by under root 13. So you can write minus 18 divided by under root 14 into 30. Just see, whatever 14 into 30 is, that will be your complete answer. That will be value of cos theta. Let's even write it. 14 into 30 will be what? 4, 2, right? 4, 2. So that is 420. It will be 420. So 420 is just under means has no root. No, it should be around 20 something, because 400 is 20. So let's leave it in root only. Minus 18 divided by under root 420. So theta will be equal to what? Cos inverse minus 18 by under root 420. Calculated the angle also. So this type of question also comes to find the angle. All right, note it down and text me when you have written it down, then I'll stop the class. No, not tomorrow. On Wednesday, we'll be having the class, same timings.
Okay, ma'am.
Okay, so as you people will be completing it, you can start leaving. On Wednesday, we'll complete the triangles law. No, not triangles law, the cross product that is left.